Hi, this is Matt Ingram returning to replication 70.1b of the results published in Legislative Studies Quarterly in February 2015. This is the replication in R. Just a quick note, I accidentally labeled this replication 70.1b at the start of the excuse me, I accidentally labeled it 70.1a at the start of the first video. It is indeed 70.1b, the replication in R. In the first video, we made it fairly far in terms of the replication steps. We replicated figure 1, the geographic distribution of the dependent variable porc10. We also generated the grid reference and then went through and replicated all the results in table 1, the ordinary least squares results, and then the the geographically weighted regression results. We also conducted several diagnostics, both pre-GWR in terms of the Monte Carlo randomization test for non-stationarity, and then we did some post-estimation diagnostics both of the stationarity and of the correlation among the GWR coefficients, among the local coefficients. What we want to do now is finish up the replication by generating the 6 maps in figure 2. So if we move to the original paper, these are the maps that we want to replicate, and let's return to where we were in R to do so. So we're at step 11, visualizing results, and in order to distinguish between the statistically significant and the non-significant local coefficients, we need to build some t-values. So skip this portion unless you're interested in other mapping options. But basically we want to move here to building some t-values. So we want to generate this new variable t nom underscore t in the spatial data frame in our GWR1 object that has our GWR results in it. So we extract the t-value, or we generate the t-value for our ideology score by dividing the local coefficient by the standard error. So we can do that for every one of our predictors to generate our t-values, and we see that it's been successful over here in the console in the top left. And the next set of plots are not that informative. I would focus here. We want to now generate distinguish the statistically significant from the non-significant local coefficients. So at the 95% confidence level, we're gonna generate a new variable that captures that statistical significance. We're calling that new variable nom95 for the nominate score 95, capturing ideology, the effective ideology, locally at the 95% confidence level. So we're adding this variable again to our spatial data frame in our GWR1 object. So first we're going to make it equal to the local coefficient. This makes nom95 equal to nom. So our new variable just took the value of all of our local coefficients, statistically significant or not. And now we're just going to replace the values of we're going to replace those nom95 with 0 where it's statistically non-significant, specifically where the absolute value of the t value is less than or equal to 1.96. So we've just done that successfully here. We can go ahead and do that for every one of the other 4 predictors. And we could also do that at the 90% level. So we could do that with this block of code here. So we'll hit Control R, do that as well. Now we can add these variables to our shapefile. So that's what this does. In the shapefile, we're going to create this new variable nom95, for instance, equal to nom95 in the spatial data frame of the GWR1 object. So that brings all of our variables that we just created, and then we can also bring over the local r squared. We could do this for the 90% confidence interval as well. These variable labels are from a different project, but this basically gives you the idea of how you do that. So you could do that on your own time. We could then now look at the names from our shapefile, and we should have 99, nom 95, seniority 95, press 95, demand 95, and power 95 plus our local R squared. So all of those variables have been brought in. If we brought in the 90% confidence intervals, the variables that are significant at the 95% confidence level, excuse me, then you would also have those there. So for now, let's skip this part here and focus here as I note in the script, trying to draw your attention to the better maps. Here are maps using quantiles, so we could again define our quantiles and then plot a map using those quantiles. And you'll see that generated on the right here. So for ideology, at the 95% level, pretty much ideology is not statistically significant west of the Mississippi. That's not precisely true because the Mississippi travels through here. But essentially in the western part of the United States, ideology is not statistically significant. It's only statistically significant in the eastern part of the United States, and you can see that that effect increases where the colors are darker. So it's 0 here, marking the non-significant values, and then the colors get go through the pink, purple, and then get progressively darker as the magnitude increases. They become more negative. So it becomes more negative up in Michigan, northern Wisconsin, northern Michigan, and then up in the northeastern part of the United States, Maine, New Hampshire, Vermont, and the very northern part of New York State. And then you see some variation in the magnitude elsewhere on the East Coast. So that's one way of mapping these. Another way, if you look at how the colors are generated here, we generated the colors based on these quintile breaks. Now we're generating colors based on the color brewer package. So this is going to be based on the red-blue scale, and that's what this map looks like. Just give it a couple seconds to draw. So that's this map here. And you see we've got 4 cuts here, so we should have quantiles. So we have 1, 2, 3, 4, 5. 5 quantiles. This is a quintile map essentially with our scale. And again, dark blue identifies the statistically non-significant effect of ideology, and then ideology becomes progressively significant, more significant. It's always significant in the non-blue units. And then the magnitude increases in the dark red. So up here, if we just look at quantiles rather than having a more continuous scale, you see that the effect is strongest in the northeastern part of the United States, plus including the northern part of Ohio, all of Michigan, Wisconsin, and then parts of Minnesota. So that's probably the most informative or the nicest map. We could do similar maps for seniority here, for the presidential vote here, or vulnerability, the variable that's capturing vulnerability, for demand here, and then for the power index. Or we could combine all 5 maps here using the R color brewer palette, the R color brewer package here. So we could generate all 5 maps here plus the local R squared map on the bottom. So we're going to generate all 6 maps at once. So that's P1, P2, P3, P4, P5, and P6. And then we could combine them all in a single plot. More equals true means that there's another plot to add. And then here you have your splits. So we could say Control R here, and a single combination map with all 6 plots will be generated, starting with the ideology plot. So there's our ideology plot in one color pattern, showing the statistically non-significant values on the western part of the United States. Then we have our seniority plot in another color palette, showing the non-significant ones in the northwestern and in the northern part of the western United States. Then we have presidential vote, demand, the power index. With regards to presidential vote and power index, you see that every unit is statistically significant. 0 is not on this scale. And demand, you see that the light gray or the very light purple captures the non-significant effect of that variable. And that's only true in California and the very western portion of Oregon in here. And then we have our local R-squared map down on the bottom right. So let's enlarge this a little bit and set it side by side with the maps from the original publication. So here's our original publication. And here are the maps that we just generated. So looking first at ideology, we could take a red pen here and note that the statistically significant effect of the ideology predictor in the original article was quite constrained to only portions of the West Coast and then portions of northwestern Michigan, Wisconsin, and almost all of Minnesota. The original publication, that is, found a very limited geographically, the statistical significance of ideology was very limited. We find that it's more expansive to almost all congressional districts east of the Mississippi. Indeed, it looks like all congressional districts east of the Mississippi, plus some that are just west of the Mississippi. So our results are maybe more generous. The results from the original publication were a little bit more conservative, but they still support each other, right? If you had to extract one general conclusion from our results, is that the effect of ideology is always negative, right? This scale is always negative in our graph, so the effect is always negative following the theory or the argument by the authors. And that effect is only statistically significant in the eastern part of the United States, and really the strongest effect is in northeastern United States. And that's roughly what you could conclude from the first panel in figure 2 that was in the original publication. Moving to demand, you also see some different patterns in statistical significance. But the effect is strongest, you would say, in the upper Midwest here. If we look at demand in our results, the statistical significance is broader. It covers more of our geographic units, but its strongest, or the strongest result, is in the upper Midwest as well. It's always positive for the original authors, and it's always positive for us as well if we look at the scale. Looking at seniority, the original authors found that seniority is also always positive, and then that effect is really strongest in the south, maybe especially in the southeast. And we find something similar, right? The effect is always positive, and it's really strongest in the south of the United States. Looking at the appropriations power index, looks like it's statistically significant across the entire geography for the original authors, but particularly strong in the western third of the country, you might say, and then in parts of Pennsylvania, maybe Virginia, West Virginia, thereabouts on the eastern part of the United States, and then parts of Illinois maybe. And in our power index, It's also statistically significant across the entire United States, but especially strong in the western quarter, maybe, of the United States, the western third of the United States, matching the main, what you might say is the core finding of the original publication. Lastly, presidential vote share. Uh, it's always negative for the authors. Wherever they find it statistically significant, it's always negative. We find that it's statistically significant across the entire sample, across all units in the United States. It's also always negative, and it's particularly prominent in the upper Midwest. So that's not quite the same as what the authors found. If they had to say anything, they would say it's particularly prominent in the South or Southwest, maybe Texas, Arizona, parts of the eastern half of the country, East Coast maybe. But the pattern looks a little bit different, although it is statistically significant. Um, Sorry, we're the ones that find it. Our replication finds it as statistically significant across the entire sample. Then if we look at local R squared, this measure of of local fit, the local fit is strongest in the southeast, the upper Midwest, and then parts of the southwest, you might say. And for us, the best fit is in the northwest. So a little variation there as well. Otherwise, though, most of the findings supported, or general findings supported, in terms of ideology, seniority, demand, and the appropriations power index. Since ideology appears to be their key variable, that's probably the one that best fits or most supports. If anything, you might say that the original authors, are more conservative in their characterization, or their results are more conservative than ours. So, looking back at the R code, that's how we would generate a plot or a combination graph that roughly matches figure 2 in the original publications. And what you might want to do at this point then is to write out the shapefile, and you could then generate the same maps in another software environment like Geoda, QGIS, or ArcGIS. So you'd use the command write OGR. You're going to write your shapefile object with all your new variables in it using the path that we defined early on in this script. You could call that new shapefile anything you want. This is the name that I've used for it here using this driver. So with this syntax right here, you would write out a new shapefile with all of your GWR findings. And that's the end of the replication. I've got some robustness checks here. These are basically the same exact analysis that we just conducted, but with different bandwidths, just to see if the results vary. I'll leave that for you, those robustness checks for you to do in your own time, and that's the end of the replication. Thank you.